So I am at the Chansik Park at Chung-Ang University in Seoul, Korea, and I'm a professor of architecture department, and I'm doing the construction management research. And today I am going to present about the construction job site safety management issues. And currently, our industry is transforming to digitalized very much. So we have to change about our construction safety activity or management practices in new way. So today I am present about the iSafe platform toward new construction safety for digitally transforming our industry. All right, so the context might in this way, and I'll overview the status of construction safety and overall, and also the platform introduction and framework, and the some technology toolkits of iSafe, and then the platform vision will be presented today. As you know about the globally, the construction, the current state is like this, right? The fatality is very much serious compared to other industry. As you see in here, over 60,000 fatal accident in construction every year in globally, and it means about one fatal accident happens every 10 minutes, right? And based on the United States OSHA data, and the financial impact of workplace injury and fatalities cost 151 billion per year. And if you just imagine that overall and globally, and how much we are wasting money-wise because of fatal injury. And also, as you see, the Korean status and in a 2020 OECD average per 10,000 workers fatality, the number, and it is very much serious. The Korea is stand and almost the end. So it is very, very serious situation in Korea. And let's go into little and specific in Korea case, the construction industry fatality rate of South Korea, as you see 2018, 2021, and you see all the over 400 numbers of fatality. Not much deduced, each status and continuously happen. So as you see that it accounted about 50% of all industry. So, and also among them, coal is accounted about the 60%, others like this. So it is very much serious in Korea. So that's why Korean government developed like this Serious Accident Punishment Act this year and imposed and implemented. So all the construction company and some corporate owners and seriously concerned about these new regulations. And let's go into the job site management practice. And as you see that when we have a project, usually we plan safety, how we're going to handle this safety risk for this project. And it calls about safety planning activities we are doing. So government actually requires the project manager and a construction company prepare how you plan and prevent and proactively the construction work safety risks like this. But in doing that, in a construction company, always the risk assessment based on document, and also the work plan site situation is not much reflected. And also, once they plan that, it has not used during the construction work during the work period. That is, document-based safety planning. They just prepared using existing the database. And also, if you take a look at the safety training practice in the industry, usually people get together, conventional classroom training introduction, and also everyday people work, and the new workers get into job site, and a construction safety manager or team leader will talk about toolbox meeting, and you need to be careful, something like orally instruct, that is it. And then all the construction activities based on their experience and their knowledge, all right? And that is the current safety training issues. So in a workspace, work types is not reflected in this training. Very short time toolbox meeting, and also in that, so in the construction workers is very much passive and ineffective, right? So it is the current situation of safety training. How about safety inspection and monitoring during the work? And inspector go move around sometime from time to time. And also, with time period, the government agencies go out to the job site and inspect what's going on. And then every day, safety manager and project manager and monitoring the job site work, right? So it happens about in-person, the manual-based, the practice. And also recently, we are using CCTV and just take a look at about the whole job site. But still, the monitoring is manually handled at the job site. So in doing that, that is a very much time consuming for inspector. And there are so many blind spots and also human errors. Even we are using CCTV, and they require monitoring step. And also it is depends on the monitoring step experience to monitor job site construction work, right? That is the monitoring the practice. How about the after work? After finishing this work, they never assess their safety performance. And currently, they just measure that how many accidents happens during the construction project period, or how much did you something happens, and also some kind of assessment is result based, right? And then they submit to the government agency or project owner, and also they just meet the legal requirements, right? So there is a quite document-based safety level assessment as happens. And in doing the assessment, the very much subjective, and we cannot believe the reliability of safety assessment document. And also government is punishment-oriented safety management culture is happens because of this kind of a safety assessment. We have changed all these major problems: planning, before work, training, and during the work, inspection, monitoring, after work assessment should be changed in some way. So that's why I propose about new construction safety and can be done like this way. So we call that this is iSafe platform, and it is about has that the major, the functional, the module. One is iSafe, I call that can be used before work for assessment, planning, and training. iSafe Guard is for monitoring, and after the assessment is iSafe incentive. So it is quite different. So in the iSafe platform is eventually I try to enhance current job site safety practices and also improve safety outcomes and saving lives. And it can be happens. It could be a new collaborative tech-driven, worker-driven safety approach, I can say. So in developing this all this functional module of this platform, I use 4D beam, digital twin technology, AR/VR, and vision intelligence, computer vision, IoT sensor, and blockchains are involved for this. Let's go into this. This is the white upper part is the current problems is document-based in a TBM training, CCTV monitoring, document-based safety assessment. So I suggest as a solution, as before work, we can make like this, the 4D beam-based risk assessment is possible for safety planning. And also training, and at the job site, real time, we can make the real 360 panorama-based training is possible. And also monitoring part, we can do that. AI and sensor-based safety inspection and monitoring is possible. So that is about video-based AI risk detection sensor and reality capture technology involves. That can be controlled safety risk at the job site. After this work and some information, workers' safety activity and project managers, construction firms, safety activities can be assessed in this way using blockchain technology by giving them more reliability information about their activities. And also, blockchain can relate it to the token and coin or some NFT things can happen. So we can incentivize safety activities as well. And then those risk level reevaluated, those job site information get into, and like this, workflow can be made. All right, let's get into the little more detail about before work iSafe solution. iSafe solution has two things. One is for planning purpose, one is training purpose. So training purpose, we are beam-based risk assessment and also generative, the algorithm is used for camera placement logistics. So let's go into there, and this is the beam-based risk assessment things. And if you have very simple 2D drawing or very light beam can be created based on 2D drawing. And then that include about space information and building object information can be obtained from beam model. And then we have everyday work schedule like this, right? So everyday work schedule happens and beam object and space information interrelated. Then in the safety accident or in a space information, spatial temporal information is linked. Then they can show about risk level visually. So that is about the system structure like this. So it can be used for big project. It can be used very small project with just simple 2D drawing and some work schedule. And then they can put that some kind of job site information like this, weather, rule and regulation, accident case data, and worker information can be attached in here. And then we can visualize before work what kind of safety the risks exist in this project. And also to monitor the safety risk, we need to attach camera and sensors, wearable or fixed sensors at the job site someplace. So that things is about generative algorithm planning. Using generative algorithm, we plan surveillance camera and sensors location. And we developed using that visual language program Dynamo, and we attach it, we link to its beam information and a safety risk information. Then we can set the camera logistics as well. And this is about training. Training tool is very much real time. We can make that. This is reality capture technology. You see, if you have 360 panorama cameras, or you can capture this panorama images at the job site like this. And then you capture the image, you can put some information there. So left part, you can use this kind of things about location move around, and safety inspector can move around the job site remotely like this way, right? And the right part is once you capture the reality 360 panorama image of job site, and the safety manager or some senior the STEM members can put some the safety information, risk information like that, right? Based on job site circumstance, situation. You can put it in there, right? And then that safety information is created and it goes to construction workers to share with that information, right? It can be used that just simple 360 cameras and can be used in this way: remote monitoring, remote inspection, and also safety information sharing and training is possible by using these tools. And the other thing is using 360 panorama image, and you can create 3D mesh information, immersive the model. We can develop it, not just using LiDAR things. And you know that the currently 3D mesh information, the model generator, and the company Metaport, those kind of company is easily low cost, very quickly you can create reality 3D mesh information. And then those created 3D mesh information can be matched with BIM, right? So based on this BIM is matched, and you can compare picture work data. It can be compared, and also you can simulate it for the BIM, all right? And then you can move get into there. So reality data comparison for the simulation and job site circumstance awareness or recognition is possible. So we can use this kind of reality capture 3D information. And currently our lab is developing a metaverse environment by using this 3D mesh information, right? So in metaverse could be one of the big technology can share workers' knowledge and experience actually. So I want to use this technology and combined with blockchain technology, and the construction workers and safety managers' knowledge and experience can be shared in the metaverse environment. Once they created, and the contents can be created like this way, for example, 360 panorama job site image or 3D mesh data can be shared, and share the BIM and the VR other data can be shared in the metaverse, and everybody, welder, bricklayer, ironworker, trade workers can create this kind of contents, right? Once they get they created the contents, and they got reward, and the token can be reward to them, and a user can join in this way. Platform will be improved in this way, right? And also expert and building trade unions and regulatory agencies, and they have so many information, infographic information, case data, and videos, animations. All those contents can be shared in this metaverse environment, and a platform can be improved, right? So, and then these expert groups can be rewarded as well, right? So we are developing the metaverse environment for job site safety improvement. Contents can be shared, and tagging and rating technology will be used, and chat, messaging, real-time avatar communication. For example, novice worker and skilled labor and the same work trade, and they get into together and they talk, right? Those kind of things can be real-time communication is possible, and groups and community will be established in the future. And also, and when we give the word, blockchain technology will ensure the reliability of information or contents. And that can be NFT-based keyword and content. The NFT, the value will be traded in this way. So something can be happens in a metaverse environment. And let's go into the during the work, I safeguard, and that is proactive safety management we are pursuing. So it has about video-based AI risk detection technology, and also synthetic data generation for AI model training, and sensor-based risk detection. And also we have smart safety hook system is along with this detection. Okay, you can see here, currently, we developed about very much diverse safety scenarios. And it caused about, we need to detect this kind of scenario, something like this. And we developed about 100 hazard scenarios. For example, outdoor scaffolding is fall from height, and that scenario might have 15 cases, right? So that is the falls from height case scenario is 52, something like the scenario structure that we develop. And then we collect each scenario data set in this way, physical data and synthetic data. And then data will be processed, labeling and annotation and augmentation, all those data processing, the things happen. And then the model will be trained and validated testing. And we go into the job site to deployment to verification purpose, like this way. So let's see in here, this is the Unity cross the platform based. We use that Unity solutions to generate the synthetic data for model training purpose. So something about, this is the 3D, the model exists, and also we have the temporary facilities like this modeling is, we create the real environment. In that real environment, we have some resource information. It's just like the construction workers, all those about us design, and then we create synthetic data. Because to AI development, detected development, getting physical data, real job site data is very much time and cost is required. So it takes a lot of time. So if we have specific, the environment can be real based representation is possible, we can create as many as possible synthetic data in this way. So we developed this generation process. We patented and we published these papers, this methodology and equipments. And this is the AI model in a detector. And we actually classified about the accident, the causing the object and equipment such as scaffolding, mobile scaffold, ladder, scissor lift, all the vehicle mounted area. This is for about falling accident, right? So it happens like this. Once we detect all these things scenario, and we can prevent, and we can warn to the construction workers and remotely, and once we implement this kind of detectors like this way, right? So to develop this the detector, we are not just in a detecting object itself. We are using so many different kind of computer vision algorithms, right? So for example, edge detection, and just 360 images. Using that algorithm, we can check about the vertical, horizontal, supporters. We can evaluate it in this way. And also object tracking is possible, tracking technology, and also object coordination technology. We can identify object coordination. We can detect the hazard situation as well. And also the computer vision, the background subtraction technology. And if you erase all the subtraction at the background, you can imagine that something about safety belt is loosens, and that means that is attached to something like technology. And also, you know that about human nerve distance can be measured with steps estimation, and also you bounding box calculation, right? You can measure about the height as well, right? So those kind of the additional algorithm, computer vision algorithm, is utilized to develop these detectors. And also our lab also combined tag and IoT is for scaffolding work, and also smart hook monitoring to prevent fall from height. Let's see in here, with camera CCTV is installed in here, worker getting to somewhere, and then you see in here, this guy identity is the recognized. You are getting to, somebody get out, we can identify. And also people go into, they have somewhere an attached smart group. We use that so many different type of hook, the sensors attached to the hook, and then we can control that the smart hook is attached or not, something like. So we developed the tag and IoT based smart hook monitoring system as well. And also people location tracking is possible if somebody get into the dangerous zone, right? And then you get into in here, somebody goes up there and you see here, right? And somebody moving into, you can see the location is identified, right? And then the smart hook attached by using smart hook, the hook, and then we can monitor that somebody is in the risk zone. We can monitor these things within 50 centimeters, 50 centimeter accuracy. We can track the location jobs. We use that UWAP installed in a POL UWA in the risk zone, and then we can go into why we do this. And you see that in the job site has the network is not stable, right? So we need to solve this data in a come and go network problem. So we developed about some kind of, the sensor based, all those things can be connected. And even the network system is unstable. So all those sensors, data should be connected. So we developed like this one. All right, let's go into the incentive part. Incentive part is kind of things about business issues. And currently, the government and project managers are always pushing workers to do something, right? So, it brings about more passive way for safety practice, right? The safety culture is created in that way. Somebody inspector comes in, they prepare some job site conditions and cleaning, all those things, and they just show that we are doing like this. So that is not enough to, prevent accident. So that way, by using this incentivized, the blockchain technology, it could bring collaborative way, worker-driven safety culture, right? And also reward can make some trading system. We can make some economy, right? So in doing that, we can use that. Previously, I explained about computer vision, AI technology can be incorporated with this blockchain technology, right? This is concept of token-based incentive system, right? So all those construction safety activities by workers and construction project managers, it used the image metadata, ADA, DDI, certificate, IoT, vision intelligence, smart card, all those things can verify workers and managers' activity. And then once this machine identify their activity is correct and proper, then token will be issued and a safety performance rated, right? And also, the construction manager safety performance will be rated like this way, right? And then token will go to this and associate some safety gear supplier, safety education institute, stepping agency, human resource, the procurement agencies. All this part are related to construction workers. So token, they accept this token and they provide service such as discount and support tuition fee and discount for goods and a discount for brokerage fee. When you go out to the job site, you need to pay some fee, right? Those kind of token can be used in this way. How about this token goes to government, right? Token, the government and agencies has safety related fund, right? Those funds can be redeemed, this token value, right? It can be, we can create voluntary safety activities possible, and also their safety performance automatically assessed. And also based on those tokens, the issuance, we can make this kind of token economy as well, right? That is the big idea. So this is general things about. So I say incentive like this, current top-down approach, no incentive, no motivation for safety performance and regulation compliance, site manager oversight and error, and limited site manager, poor reliability, say management record. It happens current practice. What if we adopt this kind of emerging technologies and individual workers' safety performance can be measured automatically? They get this kind of incentive or reward. How about foremen who hired workers? They can also, their safety performance can be assessed. And how about subcontractor who hired foremen, right? We can assess it. How about contractors? And how about project manager, construction manager, and a surveillance people can be measured. All this information can be shared with outside associate, equipment supplier, material supplier, certification bodies, structural consultant, safety inspection agencies can use their performance like this. Once we capture all this assessment data, that can be used project bidding purpose. And also it can be the workers' compensation. Insurance company or bonding company can use this kind of safety performance. Just like we have black box camera in your car, and a car insurance company provided about discount because you use that new technology, right? So this kind of bottom-up approach can create voluntary safety activity through establishment incentive system and ensure adequacy and reliability of generated information through blockchain and verification technologies. It is possible. Currently, our lab having a iSafe coin we are developing now. And also, we have some demonstration project for scaffolding procurement process. We developed the blockchain system as well. So it can be extended using this blockchain incentivized system will be extended in the future. Right, this is the our final vision of iSafe platform. If you see in here, and this platform, iSafe platform, has some kind of, we can overcome cultural legislative failures currently existing, right? That is punishing, blame culture, subjective document-based safety assessment. There is no incentive, motivation for safety performance, right? This incentive system can encourage this barrier can be overcome, right? How about this information sharing training? That is organizational managerial failure. Ineffective document based safety planning and training is not tailored to specific workspace and work types. This is very much passive education training methodology. So what our iSafe solutions, planning for and training can overcome this. We can make our safety climate goes up in this way. How about monitoring technology? And currently unsafe act cannot be monitored properly, and job site unsafe conditions. Nobody can inspect and monitor it. And it happens, errors and oversight, violation of regulations. And there is so many unforeseen hazards exist at the job site, okay? So by employing these kind of solutions, as I explained today, introduced, can prevent accident and injuries. We can save few lives in the construction job site. In this way, we can bring new way of construction safety culture and safety climate in the organization, I think. Thank you for listening. I will finish up my presentation. Thank you.